Good morning, students. Today, we shall discuss the next set of questions related to kinematics in one dimensions. In the last video, I had discussed some preliminary questions based on this. That was introductory set of numericals. Today, also some selected numericals I shall discuss, which will cover almost the entire concepts needed for this particular chapter. So I presume that you have done the revision work and you are ready to solve the numericals. Here goes the first question. Four graphs are given A, B, C, and D, and these graphs are between position x and time t. Position time graphs are given. The question is, in which of these graphs the average velocity v average over some time interval 0 to capital T, where t is some suitable time, it can vanish. What should vanish? Average velocity. Out of these four graphs, where does the possibility lie to have zero average velocity during certain interval? Now here we need two concepts. First, that if you have position time graph like so, let me choose some other graph like this, and suppose two time intervals are given. Say this is t1 and this is t2. So between t1 and t2, if we have to find the average velocity, so corresponding points on the graph you find out, join them by a straight line and find its slope. This slope will give you average velocity during the interval t1 to t2. This is the concept. And how do we find the slope? Slope is tan of the angle which that straight line would make with time axis. So this becomes equal to tan alpha. So you need to know how do we find slopes, number one, and you also need to know the concept that the average velocity can be obtained from xt graph by finding slope of a straight line joining those 2 points which correspond to the instants corresponding to the time interval. So using these two concepts, now the interval, the left side, it is given, it must be 0. That means we must start from 0. So here we must, at t is equal to 0, the graph is here in first case, in second case it is here, third case it is here, fourth case it is here. Now it gives it is asked that it should vanish, the average velocity should vanish. That means this slope should be 0. The average velocity will be 0 if this slope is 0, and you know slope is 0 means the line should be parallel to the time axis. It should not make some inclined angle with the time axis. That means the straight line must be parallel to time axis and it must pass through this. Now if you try to draw a line like this, it will never cut this graph at any other point. So this is not possible. If you try to draw a line parallel to time axis from here, it will cut the graph again at this point. So this is the required time t. So during this interval 0 to t, the corresponding points on the graph are these two. If we join them, we get a straight line. And for this straight line, this slope is how much? 0. Slope of xt graph gives average velocity. So average velocity is 0 during the interval 0 to t. So this is correct. Let us see others. Here, if you try to draw a line parallel to time axis, it will never meet the curve. Here also it will never meet the curve. The line will be like so. So out of these four options, option B is the correct answer. Okay. So this was the concept. Let us now try to solve question number 2. This question reads, an object falling through a fluid has acceleration given by this equation. A is equal to g minus bv, where v is the speed of the flowing object which is flowing, moving in the fluid. G is acceleration due to gravity, and b is some constant it is given. And it says after a long time of release, it falls with a constant speed. Find the value of this constant speed. Basically, what it is given, suppose there is some fluid. For example, raindrop, a drop of rain falling through air, falling through air. So initially, when the raindrop starts flowing, or whatever body is given in the question, initially its speed will be zero. It starts from rest. So initially, its acceleration will be g minus 0, that is g. It falls down with acceleration g. As it falls, because of this acceleration, it will gain some speed. Its speed will go on increasing. As its speed increases, its acceleration will decrease because it is given by g minus b phi. If the second term will increase because of increase in phi, then this term has to be subtracted from the constant g. So as v becomes more and more, the second term will increase. As a result, the entire expression g minus bv will decrease. So a will go on decreasing. Acceleration will go on decreasing. So it gives you a clue that there must be some instant where this acceleration decreases to zero. What would happen then? If acceleration reduces to zero, that means after that there is no increase in velocity or the speed. So at that instant and beyond, acceleration will be zero. That means the velocity will become constant. So that's why it is given after a long time of release, the object falls with constant speed because of the reason I explained. Find this constant speed. It's a very simple question, students. Because it is given, it moves with constant speed. It means after that instant, its acceleration should be taken as zero. Now, if acceleration is zero, I can put in this expression, we'll get a g minus bv will become equal to zero. And in question they have asked find this constant speed. It's very simple. So g becomes equal to v into b. V will become g by b. This is the answer to this particular question. So these two are some simple basic introductory questions. Let us see some more questions. Let us see next question, question number 3. Here in this question it is given that there is some ball, that ball is released from rest. So its initial velocity is 0. And it is released from a height of 19.6 meters from this height. So this is the height of the ball. It falls onto the ground. After falling to the ground, after that impact, it rebounds. And it is given that the ball rebounds to same height as its initial value. So it falls from 19.6 meter and it rebounds, and after rebounding rises again to 19.6 meter. This is possible only if the speed with which it hits the ground is equal to the speed with which it leaves the ground. If these two speeds will be same, then only then these two heights will be same. If it loses some of its speed, which actually happens, so this is an ideal case when there is no loss of initial energy. Generally, what happens if a ball is released from some height, after hitting, it loses some of its energy, it rebounds, but it does not rebound to same height. Again, in next collision, it will lose some more energy, and this continues till it finally falls onto the ground. But here it is given that you should assume it to rebound with same speed as the speed with which it hits. Origin is taken as this point O, the initial point where the ball was lying, and vertically downward direction as indicated in this figure is taken as the positive x-axis. With these assumptions, you have to draw approximate plots for position time, velocity time, and acceleration time graph. See, there is only one force on this ball when it falls down or when it is rising up, that is the force due to gravity, which produces an acceleration. You know that acceleration is acceleration due to gravity. Except at this point, when it hits the ground, at all other points, there is only one acceleration, that is acceleration due to gravity because of the force of gravity. At this point, apart from the gravity, there is some reaction offered by the ground. So the time during which the ball remains in contact with this ground, during that time, the acceleration will not be equal to acceleration due to gravity, because there is some extra force in addition to gravity. Who is exerting that force? The ground. In which direction? Upward direction. When that ball hits the ground, exerts a force in upward direction. Because of that force, it rebounds. But it is given, to make the thing simple, it is given that you have to neglect the time of impact. That time of impact is negligible. Okay? Otherwise, the graph will be a bit complicated. So, first of all, we shall plot AT graph. This is time, this is acceleration. Now, before we plot the graph, what is the value of acceleration? Suppose we take it as 9.8 meters per second square. Now, you know acceleration due to gravity is in downward direction, and downward direction is to be taken as positive as per the convention in this question. This will be positive. So this is 0. So plus 9.8 will be somewhere here, suppose, meters per second square. So because acceleration is constant, therefore the graph will be a straight line parallel to time axis. So this is our acceleration time graph. Next one will plot velocity time graph. To make the graph more informative, we should calculate after what time does the ball hit the ground. So that we can do is simply by using the equations of motion. From graph also it can be calculated. You see initial velocity is 0. The displacement during downward motion is 19.6 meters. So knowing these two, we can calculate the time taken. So S is V naught T plus half AT square. Initial velocity is 0. Displacement is 19.6. Half acceleration is 9.8. Both acceleration and displacement are in downward direction. They are positive, into T square. So 9.8 into 2 is 19.6. 2 into 2 is 4, and T square is 4, will give you T equals to 2 seconds. Other parameters you can calculate yourself. You will find that the time taken by the ball to fall to the ground will be equal to the time taken by it to rise to same height. So time of descent 2 seconds, time of ascent 2 seconds, total time will become 4 seconds to reach to the initial position. So we will plot our graph from 0 second to 4 second. So this is 0, suppose this is 2, this is say 4. So up till 4 seconds we will draw the graph. You should understand that at t is equal to 0, the ball is here. At this point, the time will be 2 seconds. Okay. Here t will be 2 seconds. And again at this position, the time will become 4 seconds. So here we'll have t is equal to 0 and 4 seconds. Let us now plot the velocity time graph. Since acceleration is constant, that is equal to 9.8 meters per second square in downward direction, this implies we know that the slope of a VT graph must be constant. Slope of velocity time graph gives acceleration. That must be constant. That is possible only if the graph will be straight line. So VT curve, it must be a straight line whose slope, it cannot be any straight line, whose slope is equal to 9.8 meters per second square. That is the acceleration due to gravity. This slope is positive. Why I am saying positive? Because slope should give acceleration, and acceleration we have written is positive. Slope is positive means it should make acute angle with, the graph should make acute angle with the time axis. So we can have a graph like this. We cannot have a graph like this. First thing, the graph should be like this. Now where to start from? At t is equal to 0. So as I told, we'll take time will take from 0 second to 4 second. At t is equal to 0 second, here the velocity is 0. So the graph will start from origin. Then we have to draw a straight line. Now this velocity will go on increasing in downward direction during its fall. So velocity has to increase. And velocity is, while coming down, velocity is in downward direction, that means positive. So we will increase the velocity, and it has to be positive like this. At 2 seconds, the velocity will become maximum. So velocity will increase from 0 to 2 seconds. At 2 seconds, I told velocity will become maximum. So I'll write it as Vm. Here I have written V. Let me write it as Vm. This is also Vm, speed. We are plotting velocity time graph, not speed time graph. At this instant, suddenly what happens? The direction of velocity changes. If you see carefully, the velocity was downward, it becomes upward. That downward means positive, upward in this question becomes negative. So suddenly, I note that word suddenly, abruptly, the velocity will change from plus Vm to minus Vm, indicating that there is sudden change in direction. Ball comes, hits, and goes. So this, the reversal in direction has to be indicated in the graph. At 2 seconds only, the velocity from plus Vm, it will shift to minus Vm. Okay. And after that, now velocity is in upward direction. Upward direction means velocity will become negative. So it is on the negative side. Then what will happen to its value? Its value will go on decreasing till at highest point its value becomes 0. So it will rise to 19.6 meters, and at that highest point, the if I release a ball from here, it will fall, it will rise to the same height with 0 speed at the highest point. So at 4 seconds, its speed should reduce to 0. From here, we have to start, we have to reach till here, so we'll join them. So this will be the nature of the curve. And this basic process will repeat itself. If we assume that the ball continuously rebounds to same height, then after this, again, you have to draw this graph, then this, and so on. Okay. So I am drawing the graph in the interval 0 to 4 seconds only. So this is our VT graph. Next, third one is our position time graph. Now position, if you see in this particular question, this position is origin. So here at this position, x must be equal to 0 at this position because we have chosen that as origin. Now downward direction we have taken as positive. If this is x is equal to 0, this will be x is equal to say 5, then 10, then 15, and so on. The final point will be 19.6 meters. The x will start from 0, and after 2 seconds, it will reach to the ground. At ground, x value will be plus 19.6 meters. Say that point will be this. And the nature of the graph, you know, x will be proportional to t square. Displacement s is equal to ut plus half a t square. We have seen here. S is proportional to square of t. The graph should be parabolic in nature. So the nature of graph will be like this. And now let me make it very clear. I can draw a parabola like this. I can draw a parabola like this. Out of these two, the first parabola which I had drawn is wrong. Now how do we know that? That you can easily judge by using the concept of slope. Initially, tell me what is the value of velocity? It is 0. How do we obtain velocity from position time graph? Slope of tangent. Initially means at t is equal to 0. So the graph should be such that at t is equal to 0, if you draw the tangent, it should be like this. If I draw the graph like so, then at this point the tangent is like so. So the tangent should be parallel to time axis, then only its slope will be 0. And then only its velocity will be 0. If you throw with some speed, then it starts its journey with non-zero speed. So the graph will start with non-zero slope. Okay. In that case, the graph can be straight away like this. There will be some slope of the tangent at that point. But when you draw this curve, it must first initially look parallel to the time axis, then you should uh, make the parabola. So I hope you understood the concept. So here initially the tangent is 0. At 2 seconds, it rises to a height of, it falls through a height of 19.6 meters. But because downward direction is taken as positive, that's why it is plus 19.6 meters. After rebounding, which happens at 2 seconds, the value of x will go on decreasing. And x will decrease to again 0. So x has increased from 0 to 19.6, again from 19.6, x will decrease to 0. 2 seconds it took for this part, remaining 2 seconds, that means from 2 seconds to 4 seconds, remaining part of the curve has to be drawn. So that will simply a replica of this, a mirror image of this, like this. Again at this point, actually I should rectify it a bit. The tangent at this point should be again 0. So it should just become parallel, Okay. Here if you draw the tangent again, so I'm writing that also. The tangents at these points at 2 second, sorry, 0 second and 4 second must be parallel to time axis. If this happens, this implies its slope will be 0. And if slope is 0, that means velocity is 0 at 0 second and 4 second, which is expected from the given data in the question. So this is a good question for beginner students when you are beginning solving questions in kinematics. And these graphical treatment, they help you analyze the situation properly, understand the question properly, and builds up your concepts. So they will really help you a lot. We'll see a couple of more questions. So let's see them one by one. Okay, let's see one more question before concluding today's class. Here a graph is shown, a straight line curve is shown between v and x, velocity and position. And if we start from origin, we can say velocity and displacement graph is given. I'll call it as position. So the vx curve is shown to be a straight line like this. Initially when x was 0, that means at origin, the velocity is v naught. And the velocity decreases and becomes 0 when the position reaches to the value x naught. If you write the complete coordinate, I can write this point to have a coordinate, just as in graph you write any point to have two coordinates, coordinate and abscissa. So here this horizontal component is how much? X naught. And at this point, this vertical component is 0, that is v naught. Sorry, v is 0. So this is x naught comma 0. Likewise, the coordinates of this point, this x component is 0 and the v component is maximum, that is this one, v naught. So we can say this is a straight line joining two points 0 v naught and x naught 0. First part of this question that is asked is to write a relation between v and x. That means you have to write the equation of this particular curve. Because it is a straight line, things are simple in this context. I'll choose one general point. In class 10th or earlier classes, you might have read the equation of a straight line is of this form. Something into some constant into x, some constant into y plus some other constant is 0. This is the general equation of a straight line. So we get a straight line like so, which has some slope, etc. Now instead of x and y, we have a parameter x and a parameter v. Such equation is linear equation in x and y. So here we need to have a linear equation in v and x. If you have not read straight lines, if you're not familiar with the equations, then also if you are just acquainted with the concept of slope, you can write the equation. Let me name these points as A, B, and this point C, whose coordinates, a general point we write as x comma y. Likewise, here the general point will write x comma v. At this instant, the displacement was x and the velocity of the particle was v. Now I argue that because it is a straight line, its slope will remain same at all instants. So this angle is alpha, suppose this angle will also be alpha. So tan alpha is equal to, I'll use the smaller triangle, perpendicular by base. This perpendicular will be v naught minus v by base will be this one. We should write actually 0 minus x. 0 minus x, not x minus 0. See, v naught minus v. We are writing the v for a, this point, minus the v for c point. Same thing we should do for the x coordinate, 0 minus x. So v naught minus v, 0 minus x is equal to the same thing we should do for this part. So this tan alpha is this perpendicular by this base. So we'll write the these perpendicular and bases in terms of coordinates. 0 x naught and v naught 0. So write v naught minus 0 upon 0 minus x naught. Actually remember that if we have a straight line, the slope of that straight line is difference of y coordinates by difference of x coordinates. So here the difference of y coordinates is v naught minus v, difference of x coordinates is 0 minus x. Again here if you choose these 2 points, so for these 2 points the difference of y coordinate will be v naught minus 0 and difference of x coordinates will be 0 minus x naught. This will give you the relation, required relation between v and x. So if we simplify it, v naught minus v into minus x naught will become equal to minus x into v naught. So this minus sign will cancel. So v naught minus v into x naught is equal to x times v naught. So we wanted a relation between v and x. We have got a relation between v and x. If you wish, you can take x naught that side and you can find v. So v will become equal to v naught minus v naught by x naught into x. This is the answer to part A. V is v naught minus v naught by x naught into x. If I am not correct, if I am correct, this is the final equation. Now part B. Using this relation, we have to obtain a relation between acceleration and the position or displacement. A versus x relation we need to obtain. And then after obtaining the relation, we have to plot the graph. So students, you just see, acceleration, how do you find? Rate of change of velocity. Velocity we have already got, but we have to differentiate velocity with respect to time. But here we have velocity in terms of position. Here we don't have time. So a bit of manipulation we shall do. dv by dx into dx by dt can be written. dv by dt can be written as dv by dx into dx by dt. Again, this dx by dt is nothing but v. This quantity is v. So we get a equals to dv by dx into v. Now let us first find dv by dx. Let me put this as equation number 1. Now, what will be our dv by dx? dv by dx is the derivative of this. But remember students, these numerals x naught, v naught, they are constants. So when you differentiate this with respect to x, v naught, x naught, those things are to be taken as constant. So constant derivative will become 0 minus. This is constant, so it will come out v naught by x naught into derivative of x. So d by dx of x. This becomes 1, so this will be simply minus v naught by x naught. Therefore, from equation 1, we will get the final expression for acceleration A as dv by dx, which I'll replace with minus v naught by x naught into v. Now v value, we will put this expression. So this becomes minus v naught by x naught into, instead of v, we will write v naught minus v naught by x naught into x. So this becomes minus v naught square by x naught plus v naught square by x naught square into x. This is the final expression for A in terms of x. So obtain a relation between A and x. This is the relation, that our acceleration is some constant with negative sign. See, v naught square by x naught is positive. Here it is given that here x naught and v naught are positive. So this term becomes negative plus v naught square by x naught square is again positive into x. So since A is proportional to x, the power of x is 1. So it is a linear equation. These things are constants. This is a constant, this is a constant, power of x is 1, power of A is 1. So its equation will be a straight line, just as the equation of any linear equation looks like. Now, so let us try to plot it. So we have to plot acceleration versus x. You see, when x will be 0 at this point, if x becomes 0, what will be the value of A? The right side, the second term will vanish. We will be left with minus v naught square by x naught. Minus means it will lie below this line. So somewhere here. So this is minus v naught square by x naught. So the graph will start from this point, and it has to be a straight line. And its slope is this one, positive. So it will look, that means it should make acute angle with x-axis. The graph will be like this. If it makes some angle, say theta, then slope of this line, that is tan theta, this is of the form y is equal to mx plus c. If you know this equation, A is like y, x is like x. So if you compare these two equations, m will be v naught square by x naught square. So m is positive, so m is slope. M is slope, and slope is tan theta. So we can write tan theta is equal to m, and that is equal to how much? V naught square upon x naught square. And c is this intercept. So this is minus v naught square by x naught, as I have represented here. So you need to have some preliminary ideas regarding the equations of a straight line, linear equations. So that is expected. Only then these things will be very much clear to you. Okay? So today I'll stop here, students. This was our second set of questions. One more class probably I'll take, wherein I'll discuss the third set of questions, some selected questions pertaining to kinematics in one dimension. So till then, take care, read well. I'll see you in the next class. Thank you, students.